In the previous video, we covered the bank account, our main types of items, and the inventory that manages the creation and organization of those items. Now, let's take a look at the storefront itself and see how this program actually manages its logic and all of the functionality that makes the storefront work. You'll see at the top that I create some variables, an actual bank account, a list of buyables generically that holds all of the stuff that the user has bought, as well as a shopping cart that holds all of the stuff the user might want to buy but hasn't yet. One thing I'll point out is that I've created both of these as just variables inside of this store class. I could have made each of these their own class separately if I wanted to spread around some of my logic a little bit, but this is a design choice I made just to kind of keep things a little bit tighter, to have fewer classes. I'm just going to deal with these things directly in my program, but totally some room for making some different choices there. Next, I actually have the store inventory itself that contains all the information about what the store has for sale. When the store is first created, this is where my program begins. I'll refer back to my runner. All it does is instantiate a store object, which causes the constructor to run, which is right here. So this is where our program actually begins. Welcome to my storefront. The first thing that our store does is set up the accounts here, which actually creates a list of my stuff that's empty. There's nothing in it so far, as well as a shopping cart that is empty as well. So neither of these has any contents yet, but they exist and they're ready to be added to once the user has gotten to that point. Then I want to set up my store, which, well, creates my store or my inventory. And you'll notice that when I instantiate my store inventory, it populates all of the items right off the bat. So this store inventory will come packaged with all of the items that I created down below here in this inventory to be referred to and potentially bought later on. Finally, I present a shopping menu, which is going to, set up accounts. I skipped over something, set up bank account. This is what allows us to actually set up the initial state about creating an account with an initial deposit. I'll let you review that. It's pretty straightforward. We went over it with the bank account as well. So here we are at the present shopping menu, which is the main experience of this application. And so you'll see that I set up this for loop for the menuing, which is going to allow this menu to be shown over and over and over again as long as the user needs to. Because each time they go down one pathway and they complete the functionality in it, when they come back to this spot, I want them to see this presented once again to remind them of all the choices that they have. And they can continue to loop through this menu, making choices and making purchases until they manually decide that they want to be finished and they can exit. So while still shopping is true, this is going to keep on looping. After I presented the user with this menu, they have a series of choices that they can make, each one directing them to a separate method I've created that processes the logic of that particular scenario. Notice there's some empty spots for you to create your own custom content here. And I also have this kind of else final case to allow for incorrect inputs to be managed, at least a little bit. Our first choice allows us to view the catalog. And here we have a new way of writing a for loop that is a bit different than the normal structure that we use. I want to show you what this would be the equivalent of. I could have created the for loop to say int I equals 0. Ooh, why did it autocomplete there? What are you doing, program? Let's come back here. For int I equals 0, I is less than, and what I want to do is actually iterate or go over the entire number of items in this store inventory. So what I would need to do here is actually say store inventory dot get full inventory list dot size. So for the size of that list, and then say I want to go through each of the items in it, so I++. What this has allowed me to do is to examine every item inside of this full inventory list size. But this is kind of a little bit long to write, so we have another way of writing a for loop, which is like this. For buyable item, the first entry you put in this type of for loop is the type of thing contained in the structure you're looking at. So this full inventory list returns a whole bunch of buyable items in one chain or big long list. So what I can say is I actually want to look at individual buyables inside of this list. And I'm going to call them item. I could have called this thing. I could have called this buyable, whatever I want to call it. I called it item here. And then a colon. And then you tell Java which thing you want to iterate over, or which thing you want to look at all the entries of. And the really nice thing about this is that Java will know inherently how many times to run this for loop, because it's contained in the reference to the list itself. So for buyable item, kind of says in store inventory, get full inventory list. It basically says, I want to look at every buyable in this list from start to end. Each time I look at it, I want to call it item as I loop through. And I simply print out the item's name at each different loop. So this is going to run as many times as there are items, and then print out each item one at a time as it loops through the whole thing. But once again, this could have totally worked. If you set up the internal logic just a little bit differently, it could totally work. But here's a different way of writing a for loop that I thought I'd show you. And you'll see it a few times in this project here. It's something that you could use if you'd like. A good chance to kind of review it and give it a try for yourself. So let's simply kind of a passive printing out of the names. Let's look at the actual purchasing here. So the user, in the way the program currently works, just has to type in the name of the item they wish to buy. So I'm going to scan that in, and I need to actually now examine, does this item exist in my inventory? So I'm going to hold an empty or null buyable, which is the item to buy. Why do I do this step here? Oops, I'm dragging. Let me do that. No, come back. There we go. Because if I don't find the item, I want there to be nothing that I'm able to buy. But if I do find it, I want to have a reference to it that's accessible outside of the scope of the loop. Meaning, if I actually created this inside of here, when the loop is complete, item to buy isn't findable because it's only existing inside of this loop. So I need to create it outside of the loop so that's findable later, but to ensure that it stays null if nothing is found, or this null value is replaced with whatever I find, which is this one, if I find a matching item. So I use the same for loop strategy. I'm looking through the full inventory, one item at a time. And in here, I'm checking the item name dot to lowercase. I want to make sure that if my users use upper or lower cases that aren't exactly the same as in my inventory, that I don't let that ruin the purchase. That would be kind of a very poor sales technique. So I'm going to force the whatever item that is in my inventory to be all lowercase, and I'm going to check if it equals the item name that the user has searched lowercase as well. So I'm forcing everything to be lowercase, and I'm checking if they're equal to one another. And if any items match what they're searching for, I'm going to let that be set to the item that they want to buy. And then if I found an item, if there is an item to buy that exists, then I want to give them the option. I say it's in stock, and I want to give them an option. Let them choose. Do they want to buy it or place it in their shopping cart? Or if they press something that's not in this menu, I kick them out. I say, purchase canceled. They didn't choose the right option here. So I have a make purchase method and I have a move item to shopping cart method that are helping me manage the movement of these things. Let's find the make purchase method down here. Make purchase from store. I send the item they want to purchase to this method. And then we check our bank account. If our bank account can afford this item. So I'm sending the bank account the cost of the item. Item.getPrice, whatever item I sent. This is generalized for any item that I send it. And if my bank account can afford it, I've reviewed what that method looks like back here already, I am actually going to be able to make the purchase of this item's price. And once the purchase is complete, I'm going to add this item to my stuff. I've purchased it, and I'm going to tell the store inventory to remove the item. This is a really important step. I can't just buy it. It has to be removed from the store. Otherwise, the store is going to keep everything, and we're going to just be creating copies of it. It's an important piece of logic. I've also provided the option, as I showed you before, to actually move item to shopping cart. Where did I put this method? Move item to shopping cart simply takes the item and it adds it to the shopping cart and it removes it from the store, because I don't want the item to be able to be bought in both spots. Otherwise, there's going to be copy and pasting issues. The item is going to be kind of like duplicating itself. Whenever I move it, I need to remove it from the spot it's being moved from. That's a pretty important piece of how this algorithm works. Okay, so now we reviewed how this kind of all works out when I want to buy an item. That's how it goes. And I'm also able to review all the items that I hold just by looping through everything in my stuff and printing out the contents of it. I've also provided a helper method to review the balance of our bank account. You can kind of read yourself. It's pretty simple. And I've also added for the shopping cart the ability to review it. If my shopping cart is not empty, so I don't actually want to do any of this logic if I don't have anything in my shopping cart yet. In that case, I just print out nothing to see here. Otherwise, if there's items in the shopping cart, loop through all of the contents and print them out one at a time. However, in my program, I want to provide the ability for the user to purchase things from the shopping cart. So I give them another little menu choice. Do they want to purchase anything from the shopping cart? And if they do, then I have to write in a specialized method, buy items in shopping cart. Let's take a look at how this one works. Well, I have some logic very much like buying an item normally, where I let them type in the name of the item they want, and then I take a look. Is there any item in the shopping cart whose name in lowercase is equal to what the user typed in's lowercase name? If there's a match, then I want to make a purchase from the shopping cart with this item that I'm looking for. Whatever item I've found, I want to actually make that purchase. And I'm able to actually later on as well remove an item from my shopping cart if I like. I think I actually didn't implement this into our main menu. So here's an opportunity for you to kind of bridge a gap of some functionality that I've kind of pre-built but just didn't plug in yet. The ability to remove items if you don't want to have them in your shopping cart anymore. And down below, some things that you can review are just a few more helping methods that allow items to move from one place to another. So you have to make sure that items can move from the store to the shopping cart and from the shopping cart to the store, as well as from the store to the user and from the shopping cart to the user. One of the challenges available for you to solve is, can a user return an item, meaning that piece of a user sending an item from their inventory back to the store? That's something I haven't built. That's an option for you to undertake the challenge of. There's a few details in this code that I haven't gone over in this deep dive, but those are for you to read over and try to make sense of and ask questions if you don't understand. But for the most part, the basic menuing ability of the store, I've pre-built for you in some rudimentary ways, and it is just ready and waiting for you to take it and expand upon it. Allow the catalog that you view not to just be simply names, but allow the user to actually view more information about the catalog. For when you actually purchase an item, for maybe you to be able to kind of get some other information about that purchase before you commit to it one way or another. To maybe, once you review the items you own, to be able to choose to return any that you've decided you don't want anymore. Or maybe you have some custom idea that you've thought of that you'd like to get some credit for by implementing it into this project as well. There's a lot of code going on. One of the core challenges of this project is to really learn to understand somebody else's code and then work hard to integrate your own content into this current structure of code. So if it takes you 1, 2, 3 hours of time to really understand and get comfortable with my code base, it's going to be well worth it, because that's one of the core challenges of this section. Please let me know if you have any questions, or if there's anything glaring that you've noticed that I've messed up. Otherwise, enjoy reviewing my code and adding your own.